So today we'll be working with indices, and I would like to start off this topic with the laws of indices. So let's talk about the laws that's guiding indices. Now, when we say indices, first of all, what do we mean by indices? Indices just means everything that has a power. So, like, let me write, when you say 2 times 2, it's equal to 4, right? But if I also write it in an indicial form, I would have written just 2 raised to the power of 2, because when a number multiplies itself, you then can count the number of times that number appears. So how many times is this number appearing? Twice, right? So you can say 2 is raised to the power of 2. This still means 2 multiplying 2, which is equal to 4. Now, this is a very good example of an indices, where the indices here is this number 2. So let me use a different color to circulate this number 2. Now, most of the time in indices, you will not be working with values that are known. Values like these are 2, like how we have it here. But we'll be working with values that are unknown. So values like A, we'll be working values like M, values like X, like the popular X we know, X and Y. These are the popular ones we know very well in mathematics. We're so used to these X's and Y's that everybody's asking, where is the X? So, but don't worry, today we'll also be working with X and Y's and M and A's and B's and C's and D's and E's and what have you. Now let's talk about the first law of indices. Now we'll start with the first law of indices. So let me clear this thing entirely. Okay, so let's talk about the first law of indices. Now, in the first law of indices, we'll be working with what they call, I think I've heard of it called addition law, or some people call it the multiplication law, but whichever one it's called, I'll just state the law, and whichever any name you'll feel like you can use for it. And it's either called addition or multiplication law. So let's use the first law. So the first law is, let me call it the addition law. It's when you have, now we're working with our A's and M's. So I say my A raised to the power of an M multiplying another A raised to the power of an N. So okay, let me use, I prefer to use X and Y. So let me use X and Y's, because as a Nigerian man, my tongue for M and N, they most times sound alike. So let me use X and Y. Okay, so now when A raised power X multiplies A raised power Y, notice something here. We are noticing that A and A are alike, right? They are the same. Now we call these numbers, these main numbers here, we call them the base. They're called the base numbers. So we'll call this A, and this one here, these real numbers, we call them the base numbers. Now the ones that is on top is called the index, or you can call it the power. So A raised power X multiplying A raised power Y, the formula tells us that whenever A raised power X multiplies A raised power Y, or whenever a base that is alike, having different powers, is multiplying each other, you just take one of the base and then you add the index. That's why it is called addition law. So you take one of the base and then you add the index. Is that okay? So let's take, for example, if we have let's take, now we did that too, but let me use a different one. Let's say we're having A raised to the power of 6 multiplying A raised to the power of 7. What will it give you? It will give you A raised to the power of 6 plus 7, and that is what? That is A raised to the power of 6 plus 7, 13. Now I'm sure you understand that whenever you have this A raised to the power of 6 was gotten by saying A times A times A times A times A times A. How many A's? 1, 2, 3, 4, 5, 6. And then we multiply it again by A raised to the power 7. That's continuing again, A times A times A, down to, let's say, 7 A's times another A. So let's say there are 7 A's, and when you add them up all together, what do we have? We have A raised to the power of 13, because that's what it means. So please, I have so many jargons here, let me take them off. Okay, so this is out now. So that's the first law. The first law tells us that whenever a base that is alike multiplies each other, just take one of the base and add the index. Is that good? So let's enter the next part. The next one is called the subtraction law. I believe it's kind of understandable. So I know by now your mind already tells you what this subtraction law will look like. It means when we have A raised to the power of X, let me do this thing very well, and then we are now, this is no longer going to be a multiplication, we are dividing by a raised to the power of y. What happens? You subtract. It will be a raised to the power of x minus y. For example, again, let's take our a raised to the power 6 multiplying a raised to the power 7. Now let's switch this multiplication towards division. So it will be a raised to the power of 6 dividing a raised to the power of 7. And then what happens is like saying a raised to the power of 6 minus 7. And what's the answer going to be? It will be what? What's 6 minus 7 is minus 1. Now this particular answer we've gotten will lead us to a new law again. But before I talk about this law, I'll talk about another means of doing this particular solving we just did. Now this is here. Let me draw a line. These are the means of doing this solving. We have a raised to the power of 6 dividing a raised to the power of 7. Now this is just the elementary means of doing it, but trust me, you shouldn't try this method that I'm just doing right now after today. So okay, let me do the easy method. The easy one is just minus 6 from 7 inside here. How many times can 6 go into 7? So no, not that, that's very wrong, sorry, forgive me for saying that. Now what I'm going to do is just take out 6 from 7. Take out 6 from 7. So when you take out 6 and from 7, what is left here is now out. Here is remaining just 1. So we have what here is then, so I'm still writing an equal to. So here is what? Here is just 1 over a raised to the power of 1, or like saying a 1 over a. 1 over a. Now I'll show you how this thing came about. It came about by saying when you have a raised to the power 6 over a raised to the power 7, what did we do? We did this. We said a times a times a times a times a. How many a's? 5 a's times a, 6 a's, all dividing 7 a's. A times a times a times a times a times a times a. How many? 1 2 3 4 5 6 7. Okay, I'm very good at counting. And then we say divide, we say cancelling it. So a cancel a cancel a and what's left? Just this a. And therefore our final value became 1, because there's everything here has been cancelled out, so just remaining 1 dividing what? A. And that's how we had this. But remember this, when we had this, instead of writing this way, we wrote it as what? A raised to the power of negative 1, right? And that brings us to the third law. The third law is called the negative index law. It tells us that whenever we have any value that has a negative sign, whenever we have any value a having a negative sign, let's call it negative x, it can be written as what? 1 over a raised to the power of that x. Is that okay? So let me scroll down. I don't want my face to be blocking what we're doing, so let's take this a little bit this way. So that's what we're going to say, that whenever we have a raised to the power of minus x is equal to a 1 over a raised to the power of x. And we showed it here. We had a raised to the power of minus 1. It became what? It became, from our final value, it became this 1 over a raised to the power of 1. But remember, a raised to the power of 1 is still like saying a. So that's why we stopped here. So for instance, if we're given a raised to the power of minus 2, what will it become? It will become 1 over a raised to the power of what? 2. Is that okay? So that is very good. Now let's go on to another law of indices. Another law. Now we've done 3 laws. Now we've done the addition law, we've done the addition law, we've done the subtraction law, we've done the negative index law. Sorry, I don't know why I'm belching. I think I just finished eating. Why am I still belching? Oh, okay, no, I just ate food. I think that's why, because I just finished eating. Okay, so let's continue here. Now let's take another law. The law is called the zero index law. Now what's the zero index law? Let me write this one out. I think it's very good you see it. Zero index. Now this zero index law tells us that anything raised to the power of 0 is 1. Now I want to spell it out very well. Anything. Okay, for example, this is what it means. It means that a raised to the power of 0 is equal to 1. Now a can be anything. If I say, for example, let's pick 5 million, I had to use a very large number so that you know it is anything. That's more than 5 million. Okay, let's make it the 50 million now, since it's now 50 million. So if I say 50 million raised to the power of 0 is equal to 1. Is that okay? Anything raised to the power of 0 is equal to 1. Anything. So, but now there's a catch there. There is a very serious catch here. The thing must be bounded by that raised to the power of 0. Now, listen, I'll say it again. That particular value must be bounded to that raised to the power of 0 for it to give you 1. What do I mean by that? Look at it. Sometimes people might be giving this number minus 2 raised to the power of 0, and they tell me the answer is 1. That is wrong. It is not 1. It is minus 1. How do I know? Because this 0, this raised to the power of 0 is only affecting these 2. It's not affecting the minus sign. Do you get me? Minus is a very, very tricky symbol. You must be very careful when you're working with anything having a negative sign. It is very tricky. But once you understand, once you get familiar with how the thing works, then your life as a mathematician is a walkover. Okay, see it here again now. But how can this be equal to 1? If I had put it as minus 2 brackets raised to the power of 0, this is where it is bounded now. It will give us 1. Why? Because when anything is put in bracket, it means it is affecting everything inside. But in this case, it was affecting only just what? Only just these 2. It was not affecting the minus sign. Remember, every number is known to be a positive number unless acted upon by a negative number, like a minus. So in this case, I can break this thing down. Now let me prove to you why this is not so. I can break this down to be equal to what? Minus 1 times 2. And then is now raised to the power of 0. Therefore, 2 raised to the power of 0 is what? Is equal to minus 1 times 1, which is equal to minus 1. You get it? Because 2 raised to the power of 0 will give us 1. And then you are multiplying by minus 1, and that gives us minus 1. That's why we had minus 1 here. But in this case, when everything is already raised to the power of 0, you get 1. So that's the law. So when I come back next time, I will treat the next laws, which is called the fractional index law, or the fractional laws, and the product law. So the next video will contain the next laws. Thank you.